Hello friends. Today's question: a vessel contains a vessel contains a mixture of 1 mole of oxygen and 2 moles of nitrogen at 300 Kelvin. The ratio of average rotational kinetic energy per oxygen molecule to per nitrogen molecule is. So this question is based on the equipiration of energy, and which is relationship between the rotational freedom degree as well as the temperature. So we start from there only. So we say the concept of equipiration energy. Concept of equipiration of energy. And which gives us that for a diatomic molecule, which is both our oxygen and nitrogen, the rotational kinetic energy per molecule is determined by the degree of the freedom. So which gives us that for a diatomic molecule, that is for oxygen as well as nitrogen, the rotational kinetic energy per molecule is determined by the degree of freedom. And the degree of freedom is 2, which is 2 at the room temperature. Which is 2 at room temperature. So we can write a formula that our energy rotational is our half kT multiplied by number of rotational degree of freedom. Number of rotational degree of freedom. So if you substitute, or let me define, K is the Boltzmann's constant. K is our Boltzmann constant and T is the temperature. So we have two gases, oxygen and nitrogen. So therefore we can write that for oxygen we have E rotational for oxygen will be equal to half multiplied by K multiplied by T and multiplied by degree of rotation, which gives us our KT. And similarly for our nitrogen we have our E rotational for nitrogen will be also equal to half KT multiplied by 2. This also gives us a KT. Now simple ratio will be equal to our E rotational of oxygen divided by E rotational for nitrogen, which is our kT by kT, and this comes as 1. So the options that are given to us is 1:1. That is option number A is correct, or we can say it is 1:1. So therefore option A is correct. Option A is correct. So this question was quite simple, directly based on the equiparation energy equation. So this completes the